Hi everyone, my name is Srinivas Makam. I'm one of the Docker captains. This video is part of my Docker networking tip series. In the first video we talked about Mac VLAN driver. In this video we will talk about load balancing options in Docker. So we'll cover both internal load balancing options as well as how Docker integrates with external load balancers. So first I will start with explaining the basics of service discovery and load balancing and how it is implemented in Docker, and then we will walk through four use cases for load balancing, and we'll do a quick demo of all these four cases. So service discovery allows microservices, which is dynamic, to discover each other. The two primary components of service discovery: one is the health check, which allows us to identify healthy services, and another is the DNS database, which maintains the service name to IP mapping. Load balancer uses the service discovery database to do the load balancing. There are standalone service discovery softwares like Console and etcd. So with Docker, service discovery is provided by the DNS server that is available inside the Docker engine itself. There are two kinds of service discovery. One with unmanaged containers, where we do Docker run. In this case, the container name resolves directly to the container IP, and we can use aliases to have multiple containers to have the same names. With services, we have a service having a service IP when we use an endpoint mode as VIP. So in this case, the service name would resolve to the service IP, and then the service IP would then resolve into the containers. When we use the other direct DNS approach, which is specified using endpoint mode DNS round robin, in this case the service name directly resolves to the container IP. So if there are multiple containers inside a service, the service name would resolve to multiple container IPs. And the service discovery is typically network scoped, so only containers in the same network can discover each other. So now that we covered service discovery, let's quickly understand what load balancing in this context means. So we would want the access to the service getting load balanced to all the containers which are part of the service. With layer 4 load balancer, the load balancing is based on the layer 3 and layer 4 fields. With layer 7 load balancer, we could use the URL fields to load balance. Load balancers also support a lot of advanced features like SSL, termination, content-based routing, authorization, redirects, and sticky sessions. Some of the commonly available load balancers are Nginx, HA proxy, traffic, and even for the cloud scenario, every cloud provider have their own load balancer. So now let's talk about how load balancing is done inside Docker. For unmanaged containers, which are not services, load balancing is done using a simple round robin scheme. In the case of services, Docker takes care of load balancing the services to the individual containers. For endpoint mode VIP, Docker uses Linux features like IPVS and IP tables to do the layer 4 based load balancing. In the Docker C edition, we don't have support for layer 7 load balancing, but we can achieve it using external load balancers. And we use the endpoint mode DNS round robin based load balancing is done. For services that are exposed externally, Docker uses routing mesh to expose the services on all these swarm nodes. And for layer 7 load balancing, with Docker Enterprise Edition, we have the HTTP routing mesh, so we can do layer 7 based load balancing. And with Docker, we can also integrate well with external load balancers. So now that we have covered the theory between the service discovery and load balancing, let's talk about the four use cases. The first one is the internal load balancer. So for this particular use case, what I have taken is a simple vote application. This is like a web server which exposes the votes that the user has entered, and then I have a client. It's like a variation of the Ubuntu container. I will be able to access the vote service using the Swarm load balancer. This is how the internals would be. From the client, I access the vote service using the service name. That would get resolved using DNS to the service IP, and then Docker would use a combination of Linux features like IP tables and IPVS to load balance to the two vote containers. So this is my Docker Compose file. So let's look at what is inside. So here I have two services, which is the OAT service, and then I have my client service. They are both part of the my network, which is an overlay network. So I have a single node swarm that is running. So let's start the service. So I do a Docker stack deploy, and I have deployed this Docker Compose file. So now the two services are deployed. Let's look at Docker service ls. Okay, so we have the client service which has one replica. We have the OAT service which has two replicas. Let's look at the running containers. So we have one instance of my client container and two instances of my OAT container. This is because I specified two replicas. So now to illustrate the internal load balancing, let's SSH into my client container. So I am now inside my client container. So now inside this, now OAT is the other service that I am running. So I can do a curl of my OAT. So note down this particular OAT container. So it's going to load balance between the two containers. So now if we do it multiple times, we're going to see that the container ID is changing because we are load balancing from our client container to the two OAT containers. So this is an example of internal load balancing. The second use case we'll talk about is the Ingress Load Balancer. In this case, the service is exposed to the outside world. So I take the same OAT service and I expose this using an Ingress network. When I expose the service using the Ingress network, we can access the service using the host name or the IP port of any of the swarm nodes. So this is how the internals of the Ingress Load Balancer would look like. Once we access from the external swarm node, it will be NATed to the sandbox IP, which is the Ingress sandbox. So from the Ingress sandbox, it will use the same swarm load balancer, which is implemented using IP tables and IPVS, and it will get load balanced to the two OAT containers. So let's see the Ingress Load Balancer in action. So we have the Docker Compose file. This is going to be much more simpler because I just have one OAT service with two replicas, and I am exposing this particular service to the swarm node 8080. So with this port number, I can access from any of my swarm node cluster. So let's just start the service. So the service is successfully deployed now. Let's just look at the service output. So all we see is one OAT service, and it is exposed using the port 8080 into my local host. So now we can access using my local host, and we can see that the request is getting load balanced to the two OAT containers. So this is an example of using an Ingress routing mesh to do the load balancing. So the third example, I kind of call it as a proxy load balancer. In this case, we will use some kind of an external load balancer like an Nginx load balancer, which will do services like maybe SSL termination. So there are some features of the external load balancer we will use in combination with the swarm load balancer. So the load balancing that is done to the service to containers, that will be done by the swarm load balancer. The only function of the external load balancer would be kind of proxying the service, and this particular Nginx proxy load balancer itself will be deployed as a service in the swarm cluster. So let's see the proxy load balancer in action. So let's look at the Docker Compose file. So this has two services. The first one is very similar to what we have looked at before, OAT service with two replicas. The one that is different is the proxy service here, which is using the Nginx, and I'm exposing this using my local host with port 8080. I'm using the overlay network. So this is the part that is interesting here. So I'm defining the nginx.conf file and ask it to do a proxy to my OAT service, which is exposing the service on port 80. So now let's start this service. Okay, so now it is deployed. So let's look at the running services. So here we have my port service and then the proxy service. So now if we access the proxy, Nginx proxy at this port 8080, it is going to proxy to my port service, which is having 2 replicas. To see that in action, so let's do curl localhost 8080. So this is, let's see the load balancing. So here we can see that the load balancing being done to the 2 port services. And here we are proxying from the Nginx proxy to the Swarm port service, but the load balancing itself is done by the Swarm load balancer in this case. The only function of the Nginx is to proxy to the Swarm port service, and then the load balancer takes into account there. So this is the last example I'm going to cover here, which is the layer 7 load balancer. So there are 2 options if you want to do layer 7 load balancer. One, in this example, what I'm covering is using traffic. Traffic is good because it can dynamically discover the services and automatically configure itself to do the load balancing. So there is no static configuration that is needed. The other option is if we can use Docker Enterprise Edition, which is UCP. It also supports layer 7 load balancer. With the Docker Community Edition, we cannot have layer 7 load balancer. We can have only layer 4 load balancer. So let's see this in action. So here what we have done is we have deployed traffic as a Swarm service. So we can access Swarm traffic service using an Ingress routing mesh and the Swarm load balancer. So the traffic will be exposed on every node. And then what we have done is we have deployed 2 services. One is a web service. I have 2 replicas of it. And then I have a vote service. I have 2 replicas of it. And then here I'm doing an L7 load balancing where the domain name /web, I'm going to load balance it to the web service, and the domain name /vote, I'm going to load balance to the 2 vote replicas of the vote service. So let's see the traffic load balancer in action. So let's look at the Docker Compose file. So first part is the traffic itself, which is deployed as a Docker service, and it's running on this TNet network, and it is exposing port 80 and 8080. 8080 is where the traffic web interface runs, and 80 is where the proxy load balancing port runs. This is the port service, and here I have used some few labels which allows traffic to do the dynamic service discovery and load balancing. And here I have specified the path as /port, and another I have a web service which is using Nginx, and I have 2 replicas, and which is using /web as the path. So let's deploy this. Okay, so let's look at the services that are running. So here we have, see the vote service which has 2 replicas, we have the web service which has 2 replicas, and then we have the traffic load balancer. So let's look at the web interface of traffic. So here we see that traffic is running with /vote, that is going to the backend vote with 2 replicas, and we have /web which is access to the web service which has 2 replicas. To see that in action, so let's try accessing this vote service at the vote path. So we can see that it's getting load balanced. Now we can also access the web service, which is a simple Nginx. So this is also going to get load balanced to the Nginx service. So here in this example, what we have done is used traffic to do load balancing of Docker services. So the same example can also be tried with UCP, and it will work exactly like the same. For folks who are deploying Docker in the cloud, Docker also integrates well with the cloud load balancers. Hopefully this video gave you a good idea of how different kinds of load balancers can be used with Docker. Thanks for watching.